What if the greatest climate technology of the future was already alive? And what if we're destroying it, acre by acre, while searching for answers in silicon and steel? Chapter 1. The lungs of Earth. More than a metaphor, when people talk about the Amazon, they often call it the lungs of the Earth. It's a nice phrase, easy to remember, poetic, but it's not just a metaphor. It's a description of something very real and very powerful. The Amazon spans over 5.5 million square kilometers. That's bigger than India. Inside it are more than 390 billion trees. Here, each one is working quietly, every second of every day. They absorb carbon dioxide, release oxygen, and cool the planet. They regulate weather systems. They make rain. They even affect air patterns as far away as North America and Europe. To give you a sense of scale, the Amazon absorbs around 2 billion tons of CO every year. That's roughly 5% of global annual emissions, just from one forest. Without it, we would already be in much deeper trouble. But here's the twist. The Amazon might not be a carbon sink much longer. In fact, parts of it have already flipped, becoming carbon sources instead. Instead of absorbing CO, they're releasing it. Why? Because we're cutting it down, burning it, clearing it for cattle, soy, and illegal logging, and in doing so, we're pushing the system toward collapse. Let's pause here. Imagine we invented a giant machine that could suck CO from the air, purify it, store it safely, and even generate rain. Imagine that machine didn't need electricity, didn't produce waste, and had been running for millions of years. We would protect that thing like a miracle. That's the Amazon, and we're watching it die. In the last 50 years, around 17% of the Amazon has been lost. Scientists say that 20 to 25% is the tipping point. That's when the system no longer recovers on its own. That's when the rainforest starts to unravel into dry grassland. And once it starts, it doesn't stop. No matter how many trees we replant after, this is not a slow crisis. It's accelerating. Fires are more frequent. Droughts are stronger. Rainfall patterns are changing. Trees that once grew tall over centuries now die in seasons. And remember, when trees die, they don't just stop absorbing CO, they release the carbon they've stored back into the air. It's like opening the tank and letting it all spill out. So here's the big question we're going to explore in this series. Can the Amazon be more than just a forest? Can it become a living carbon machine on purpose? Not just a passive sponge, but something we intentionally support, expand, and even enhance. Can we turn the Amazon into the centerpiece of our climate survival plan? Because here's the hard truth. Most of our climate solutions are built for the long term. Solar panels, wind turbines, carbon markets, electric vehicles, they work, but they take time, decades. And time is not something we have a lot of. But the Amazon is already here. It's already working. If we protected it better, helped it grow, repaired what we've destroyed, we could boost the amount of CO it removes from the air immediately, not in 2050. Now, and that's not science fiction, that's science, right now. For example, studies show that secondary forest areas that were once cleared but are now regrowing can absorb carbon up to 11 times faster than old-growth forests. That means rewelding degraded land could be more effective than planting new trees from scratch. Even better, protecting the Amazon doesn't require building anything new. It just means stopping the damage and letting nature do the rest. The return on investment is off the charts. For every dollar spent on forest protection, the value in carbon storage, biodiversity, and rainfall regulation is massive. But the challenge is not just technical, it's political, economic, and emotional. The Amazon stretches across 9 countries. Each has its own laws, priorities, and pressures. In Brazil, for example, economic growth often depends on agriculture and resource extraction. That creates tension between short-term profits and long-term survival. And then there's the global side of the problem. Rich countries talk a lot about saving the Amazon, but often fail to support it financially. Meanwhile, companies around the world benefit from cheap beef, soy, and timber that come from cleared rainforest land. If we're serious about using the Amazon as a carbon solution, we need to shift how we think about it, not as someone else's responsibility, but as part of our shared survival. This forest doesn't just belong to Brazil, or Colombia, or Peru. It belongs to the atmosphere, and we all live under the same sky. In the next chapters, we'll go deeper. We'll explore the risks of tipping points. What happens if we lose control? We'll look into future technologies. Gene-edited trees, microbial soil enhancers, AI power. We'll also talk to people who already live their indigenous communities, who've managed these lands long before any climate scientists arrived. Because maybe the answer isn't to build a new machine. Maybe it is to understand the one we already haven't. Make sure it doesn't stop working. The Amazon is not just a story about trees. It's a story about time, balance, and decisions we're making now that will echo for centuries. So stay with us. The next chapter will show you just how close we are to the edge. Chapter 2, Tipping Points and the Death Spiral. Talk about something scientists fear but that most people have never even heard of. Tipping points. A tipping point is a moment when a system suddenly changes and you can't go back. It's not gradual. It's not fixable. It's like pushing a glass toward the edge of a table. For a while, everything seems fine. Then suddenly, it falls and there's no putting it back together. Right now, the Amazon rainforest is dangerously close to that edge. For decades, the Amazon has absorbed huge amounts of carbon dioxide, but that ability depends on a delicate balance between rain, soil, temperature, and tree cover. When that balance is broken, the whole system starts to unravel, and scientists believe we're about to cross the point of no return. Research from the Brazilian National Institute for Space Research and international climate teams shows that if 20 to 25% of the Amazon is lost, the rest could collapse. Not all at once, but fast. What used to be rainforest becomes dry savanna. The humidity drops, the rain stops, the trees die, the ground becomes grassland, the rivers shrink, and all that carbon the forest once locked away, it gets released back into the atmosphere. This is what's called a feedback loop, and it's the stuff of climate nightmares. Here's how it works. Less forest equals less rain. The Amazon actually creates its own rain through a process called transpiration. Trees release water vapor, which forms clouds and eventually rains back down. When trees are cut, that water cycle breaks. Less rain means more drought. More drought equals more fires. With less moisture, even small fires can turn into massive blazes. These aren't natural forest fires. They're man-made and they spread fast. More fires equals more carbon released. Not only do fires destroy trees that capture carbon, they also release decades worth of stored carbon back into the air. More carbon in the air equals more global warming. And global warming means even more drought, more fire, and more forest loss. That's the loop. And once it begins, it feeds itself. It accelerates, and we lose control. This is what scientists call the death spiral. We don't know exactly when it starts. There's no flashing red light, no countdown, but signs are already here. In parts of the southeastern Amazon, the forest has already stopped absorbing carbon. It's emitting more than it captures. Some researchers have even found that in the dry season, the Amazon becomes a net carbon source. That's not a prediction. That's happening now. And that has global consequences. You see, the Amazon isn't just a local ecosystem. It's part of the planet's climate engine. The water it evaporates falls as rain thousands of miles away. The carbon it absorbs cools the entire atmosphere. When that system fails, it's not just South America that suffers. It's all of us. Weather patterns change, crops fail, sea levels rise faster, and extreme events from wildfires in California to floods in Europe become more frequent and more intense. So what do? We stop the spiral before it starts. That means understanding the drivers behind the destruction and acting fast. The number one cause of Amazon deforestation is agriculture. Forests are cleared for cattle grazing and soy plantations. Much of that soy goes to feed livestock in other countries. In other words, global diets are shaping the fate of the forest. Another major factor is illegal logging. Despite laws and satellite monitoring, large parts of the forest are cut down in secret and sold into international markets. And then there's infrastructure: roads, dams, and development projects that slice the forest apart and make it easier for illegal activity to spread. Each cut, each burn, each cleared acre might feel small, but together they push the system closer to collapse. We often think of climate change as something that's far away. Ice melting in Antarctica, sea level rise over decades. But the Amazon tipping point could happen within our lifetime. Some say it could happen within the next 10 to 20 years. And once it does, we can't engineer our way out of it. There's no backup rainforest, no replacement for the Amazon. It took millions of years to build. It could fall apart in decades. But here's the strange, hopeful part. Because the Amazon is still functioning just barely, we still have a window, a narrow one, but it's open. If deforestation is reduced, even by small percentages, the forest begins to recover. Satellite data shows that areas allowed to regrow start capturing carbon again within just a few years. The water cycle reboots. The fires fade. The feedback loop slows. In fact, some scientists believe we can stretch the tipping point, push it further into the future, by restoring degraded land and protecting what remains. And that's where the next chapter of this story begins. Because if we accept that the Amazon is near a critical threshold, the question isn't just how do we stop it from collapsing, it's how do we help it grow stronger? Can we guide the forest into something even more powerful than it was before? Not just by protecting it, but by working with it, enhancing its abilities, amplifying its strengths. Could the Amazon become a living machine not just by nature, but by design? That's the idea we'll explore next. Chapter 3. The Terraforming Blueprint. Let's imagine something for a second. Picture the Amazon not just as a jungle, but as a kind of living machine, one that's been fine-tuned over millions of years, with mechanisms we're only now beginning to understand. The trees, the fungi, the rainfall patterns, the carbon exchange, all of it working together like a vast biological computer. Now imagine tweaking this system, not destroying it, not replacing it, but enhancing it. That's the blueprint, and it starts with reprogramming niche. The term scientists are using is assisted resilience. It's not about turning the rainforest into farmland or replacing it with labs. It's about helping it do what it already does, but absorb carbon just more efficiently. The Amazon already takes in around 2 billion tons of carbon dioxide every year. That's impressive, but it also releases almost the same amount due to deforestation and degradation. In its current state, the balance is fragile. What if we could tip that balance? Biotech researchers are looking into gene editing, not in the controversial sci-fi sense of glowing trees or synthetic plants, but subtle changes, small adjustments to root systems that let trees store more carbon underground, modifying microbial communities in the soil to increase absorption. Think of it as upgrading nature's own tools. These ideas sound like science fiction, but they're based on real, peer-reviewed studies. In labs around the world, scientists are growing test plots with superfungi that work with tree roots to pull more carbon from the atmosphere. Others are developing drones that plant trees in a precise pattern to maximize photosynthesis and reduce heat stress. This is engineering with a soft touch, bioinformed, not bioimposed. But there's also a human element to this blueprint. Any transformation of the Amazon must work with the people who live there, not against them. Indigenous communities have managed these forests for generations without pushing the ecosystem to collapse. They understand rhythms and balances. Modern science is only now catching up with. Some experimental projects are already involving local tribes in co-designing reforestation models. For example, by combining traditional knowledge of species diversity with AI-based simulations, researchers can predict which tree combinations will best survive climate extremes and maximize carbon uptake. It's a weird blend of ancestral wisdom and cutting-edge tech, but it works. Then comes the data. This blueprint depends on feedback loops. Satellites and drones can now monitor the Amazon in real time, measuring everything from canopy density to carbon concentration in the air. With the help of machine learning, these vast data streams can tell us which areas are thriving, which are failing, and what changes are making a difference. The forest starts speaking in numbers, and we begin to understand the language. One example already underway is Project Arbo, a collaboration between ecologists and computer scientists that maps carbon corridors. These are areas where restoring even a few key species can reopen broken carbon highways between ecosystems. The result? A kind of vascular system, pumping carbon into long-term storage underground, not in tanks, but in roots, fungi, and deep organic layers of soil. This is not carbon capture. As we know, it's biological sequestration on an enormous scale. Still, the challenges are huge. It's one thing to engineer a few thousand acres of forest. It's another to apply these methods across millions of square kilometers. Mistakes could backfire. Introducing the wrong microbe or overplanting a single species could unbalance everything. So these interventions must be adaptive, constantly re-evaluated. That's why every element of this terraforming plan must be monitored in near real time. And there's a deeper question at play. Should we be doing this at all? Some argue that even a soft touch is still a kind of control, humans once again trying to dominate nature, even under the banner of saving it. But others see it differently. They argue that we've already altered the Amazon just by existing. Climate change, pollution, agriculture, it's already happening. Doing nothing is also a decision. So instead of stepping back, they believe we should step forward carefully, respectfully, informed by both science and ethics. The blueprint doesn't promise miracles. It won't stop climate change alone. But if successful, it could turn the Amazon from a carbon-neutral zone to a carbon-negative one. That would be a game-changer not just for South America, but for the planet, and not in a distant, abstract way. A more stable Amazon means more predictable rainfall patterns in Africa. It affects jet streams over North America. It could literally alter global weather. We often talk about terraforming Mars, about creating a second Earth in some distant future. But maybe the real challenge isn't building new worlds. Maybe it's saving the one we already have. Maybe the Amazon is our test case, not for escape, but for return. For seeing if we can take responsibility for a system we never built, but entirely depend on. In the next chapter, we'll look at the economic engine behind all of this. Because, no matter how advanced the science becomes, none of it moves forward unless someone funds it. And the new Amazon might not be just a forest. It could be the first ecosystem with its own carbon economy. But that future, it comes with trade-offs. Serious ones. Let's talk about that next. Chapter 4. The race to bioengineer the rainforest. Here's where things get both exciting and unsettling. With the Amazon tipping closer to a point of no return, scientists, biotech companies, and even defense contractors have started asking a bold question. What if we don't just protect the rainforest? What if we reprogram it? It's not science fiction anymore. Right now, teams around the world are working on genetically modified trees designed to grow faster, suck in more carbon, and survive longer droughts. These are not regular plants. They're engineered to thrive where native species are struggling. Think of them as carbon-hungry machines disguised as nature. The most famous project so far, something called the Super Tree Initiative, backed by a coalition of universities and climate tech investors. The goal is simple but radical. Plant 1 billion bioengineered trees across degraded regions of the Amazon by 2040. Each tree is coded to do 3 jobs. Pull in more CO than a standard tree, release less methane, and connect to underground fungal networks to spread those traits across native species. Sounds like a dream, but here's where the debate begins. Some scientists worry this is a dangerous path. Ecosystems evolve over millions of years. Introducing even one new species, let alone an entire forest of modified ones, can create cascading effects we can't predict. What if these trees outcompete native plants? What if their altered genes spread uncontrollably? Or what if the underground fungal networks critical to rainforest health get disrupted in ways we don't yet understand? But others argue we no longer have the luxury of waiting. The Amazon is changing faster than nature can adapt. Fire, logging, and heat are pushing it past survival thresholds. Without intervention, parts of it will become savanna in our lifetime. In that scenario, doing nothing is the bigger risk. So, who's leading this race? One of the most ambitious players is a US-based startup called Carbon. They've developed tree embryos embedded with nanotech actual sensors that monitor moisture, CO absorption, and stress levels. The idea is to deploy these smart trees in strategic zones, then collect real-time data on how they perform. Some even suggest these forests could become early warning systems, detecting signs of ecosystem collapse before it's visible. Meanwhile, a Brazilian team at INPA is taking a more cautious approach. They're restudying how indigenous agroforestry methods can be combined with low-intervention genetic tweaks like boosting drought resistance without touching reproductive traits. Their motto, respect the forest, don't rewrite it. This tension between urgent action and ecological humility is defining a new era in conservation. It's no longer about just protecting what's wild. It's about asking what happens when we design wildness itself. And the stakes go beyond trees. Because if bioengineered forests work in the Amazon, they could be replicated across the planet. Africa, Southeast Asia, even deserts. We might see a world where climate recovery is outsourced to custom ecosystems, forests as technology coded to save us. But that raises a chilling question. Who controls this technology? Who decides what a forest should look like? And if a rainforest is no longer wild but optimized, monitored, and some philosophers call this the end of wilderness, a future where nothing is untouched, and every leaf has a purpose defined by code. Sufficient. It's measurable. But is it still nature? And here's a twist. What if this new rainforest becomes more valuable because it's artificial? Think about it. A natural tree might take 30 years to grow. A modified one could do the job in 5. That's attractive to carbon markets. It's attractive to governments looking to hit climate targets. Suddenly, planting the old forest seems like a bad business decision. That's where ethics collide with economics. Some indigenous communities are already pushing back. They argue this is a new kind of colonialism, replacing their land and knowledge with patented genes and corporate logos. In their eyes, the forest doesn't need fixing. What needs fixing is the mindset that sees nature as a system to be hacked. Others are cautiously open to collaboration, include local voices in decision-making. There are promising models where tribal leaders co-design forest zones with scientists, blending ancient planting techniques with modern monitoring tools. It's not perfect, but it's a step away from domination and towards stewardship. Still, the pressure is building. Every year without meaningful carbon reduction brings us closer to climate tipping points. Geoengineering solutions once considered fringe are becoming mainstream, and the Amazon is ground zero for these experiments. We're entering an era where forests might be grown, not just from seeds but from lines of code, where drones plant trees, where satellites check their performance, where nature is redesigned for efficiency. Is that exciting or terrifying? Maybe it's both. Because if we get it wrong, we could accelerate the very collapse we're trying to prevent. But if we get it right, if we respect the complexity of ecosystems while guiding them with care, we might just turn the Amazon into something new. Not the same forest it once was, but not a machine either. Something in between, a living system. Chapter 5. The Amazon's New Identity, a blueprint for Earth's survival. Let's imagine a moment in the near future. Satellites orbiting high above the Earth send back data not just about cities, oceans, or glaciers, but about something strange in the heart of the Amazon. A pulse, a pattern. The forest, once only a passive victim of climate change, is now an active force fighting against it. It's become something new, not just a rainforest, but a living system carefully managed, deeply understood, and more powerful than we ever thought possible. This is no longer about preservation, it's about transformation. In this new identity, the Amazon becomes a model, a blueprint for how we might survive as a species. Across the globe, countries begin to replicate its success. Africa's Congo Basin becomes a center of ecological innovation. Southeast Asia's tropical forests are restructured around carbon capture and biodiversity recovery. We've shifted from exploitation to symbiosis. But this didn't happen through hope alone. It took science, it took risk, and it took one uncomfortable idea that we had to intervene, not destroy, but design. Let's be clear, this isn't about turning the Amazon into a farm or a factory. It's about understanding its rhythms well enough to support them. Precision-controlled burns that mimic ancient indigenous practices, genetically selected species that store more carbon, faster, a fusion of traditional knowledge and frontier technology. In this scenario, AI doesn't just map deforestation, it predicts forest stress weeks in advance. Drone swarms plant billions of seeds in hours. Satellite networks feed real-time data into carbon markets, allowing trees to earn value just by being alive. And here's the catch: this isn't science fiction anymore. Pilot programs are already underway. In parts of Brazil, community-led carbon credit systems are showing that conservation can be profitable. In Peru, machine learning models are identifying which areas can recover. In Colombia, drones are seeding former cattle-lands with climate-resilient flora. These are early sparks, but if they catch, we might see a transformation not just of the Amazon but of our entire relationship with nature. But there's a deeper layer here, a philosophical shift. For centuries, we treated nature as the other, something to tame, conquer, or romanticize. The Amazon was either a resource to exploit or a pristine wilderness to protect from afar. But now, we're beginning to view it differently, as a system of intelligence, not conscious in the way we are but still capable of memory, feedback, and resilience. In this sense, the Amazon becomes less like a thing and more like a being, one we can learn from, one we might even collaborate with. This new perspective forces us to ask strange questions. Could forests evolve faster with our help? Could ecosystems become partners in planetary maintenance? And most challenging of all, can we trust ourselves enough to guide that process without falling back into old habits of control? The truth is, this new identity of the Amazon isn't guaranteed. It's a fork in the road. One direction leads to collapse, the other to co-creation, and time is running out to choose. We're not just observers anymore. We're participants. Whether we act or do nothing, we're still shaping the outcome. The most hopeful part: the forest is not waiting on us. It's already trying to adapt, to regenerate, to stabilize. The question is, will we meet it halfway? Imagine a future where we look back and realize the Amazon didn't just absorb carbon. It changed how we think about life on Earth. It taught us that nature is not a static museum, it's a living system with the potential to heal if we learn to listen. And maybe, just maybe, the Amazon's new identity will be the spark that finally shifts our global trajectory from a civilization built on extraction to one built on balance. So if this idea moved you, take a moment, leave a comment, share your thoughts, or hit that subscribe button. We're only just beginning to explore these possibilities together. And who knows, maybe the next big solution starts with a conversation right here. If you believe nature is more than a victim, if you believe it can be our partner, let's keep this conversation going. Drop your thoughts below, hit like, and subscribe for more journeys into the near future.